Hello, everybody. Hi, my name's Dylan. I'm president of Robotics at Maryland, and I'm joined by Manny, who's our mechanical lead, and we're presenting on behalf of all three of our teams. So we may only have 6 minutes. We may be going pretty fast. However, we'll be over by the table for the rest of the day. We'll be happy to answer any questions you may have. Our main goal, our self-declared title, is that we're pioneering the future of autonomous systems. And some of you may see us as undergrads and say, get your PhD and maybe then you can say that. But we do mean pioneering the future in terms of supporting undergraduate education. Our main goal is to cultivate a holistic understanding of robotics, encompassing design, fabrication, assembly, and testing to equip members for real-world engineering challenges. And that's a long way of saying that we build everything from scratch, from start to finish. We ideate the problem, we put together a business plan and Gantt charts, and we go from start to finish building a robot. So there's a lot of mechanical, electrical, software experience, technical experience, as well as administrative for myself. We also have another slogan, taking UMD land, air, space, and sea. This is because we are starting to develop into a platform for robotics clubs to come to us so we can give them the logistical, financial, and technical support to actually create their platforms. So our first platform was actually Cubo, which I'll get into for the RoboSub competition, but now it's expanded into our Test2Dog quadruped robotics team and our Terraformers Mars rover team, which is our newest branch. All of these teams will compete in competitions across the globe, and I'll get into that next. You can see some of our robots here. Cubo was first idealized in 2014 with another robot before that. It's a submersible that's fully autonomous. We have Test2Dog. The name speaks for itself. It's a quadruped robot dog, and we plan to compete in quadruped races. This year was held in Japan. It's held in every different places each year. And we have the Flying Turtle and Terry the Terraformer, which is part of the University Rover Competition, or URC. They compete in Nevada every year. So all of these robots come together to form one very large organization. Let's talk about one at a time first. This is Cubo. He's over on the table. Cubo is a submersible. This means that it's able to be underwater and it's neutrally buoyant, so we can then manipulate ourselves similar to how astronauts move around in space. We have 8 thrusters that allow for pretty precise turning, roll, pitch, and yaw, as well as implementing fully autonomous operation, like I mentioned, including an IMU, camera, Doppler velocity logger, and a lot of other things. Here you can see a brief GIF of our pre-qualification in a neutral buoyancy lab. We have to go around that pole, through the gate, and back through the gate again. So you can see our autonomy finishing the pole loop and then going through that. And then this qualifies us for semifinals. And we were actually able to become finalists this year for the first time in probably over a decade. It was a huge milestone for us. We were able to do this through a lot of very hard work from our leadership, as well as technical abilities, and a lot of hours. Here you can see an example of what we did during the competition. Let me play that again. What's going on is there are symbols on a buoy under the water, and we have to use machine learning, which we use YOLO v7 and RoboFlow to do so, to autonomously navigate 2 certain symbols, which are randomized each time. So you can see us bouncing into that top right symbol and getting points there. This competition is held in it's an international competition, so every year we'll be in San Diego, California. This year there's 54 teams from across the globe. Last year, University of Bangladesh and University of Singapore actually took home first and second place. So it's a great way to meet engineers from a diverse set of backgrounds and also learn from people across the globe. There we go. And then let's talk a little bit more about the technical aspects of Cubo. We have the pneumatic system, which is our biggest milestone reached. This has been a 2-year project. We decided, hey, our servos are leaking water into our hull, and it's going to cost us thousands of dollars if water gets on any of this stuff. Servos are unreliable. We wanted to make our own system from scratch, have that learning experience. So we actually were able to create a custom enclosure to produce a pneumatic system that basically uses compressed air from a paintball tank to actuate pistons. And from here, we can use this on our end effectors. Here's one example. We have our torpedo launcher. This is actually a self-powered torpedo, and all the piston does is actuate the limit switch up there, and then that will activate a supercapacitor, which spins a motor. It's actually a really cool idea that we've been working on. We also have the claw and the dropper. The claw is pretty simple, just a rack and pinion mechanism. And then we have the dropper, which uses the piston to almost reload the cartridge back and forth to drop an object into a bin. And the goal of all of this, for context, is to score points, and whoever gets the most points wins the competition. Now let's get into more of the Test2Dog highlights. Here's our most recent iteration. The main goal of this is to compete in IEEE's Robotics Challenge. It's a very, very new thing. Each year they host a quadruped robotics race. So you can see the actual obstacle course in the plywood there. You have 3, 2, 1 go between 2 robot dogs, and they have to autonomously navigate this obstacle course. And luckily for us, they create the entire simulation in Gazebo, so we're able to simulate it first, and then from there navigate it later. Something to note is that there's only one dog that's built from scratch, the one that's fully red there. Everything else is kind of sort of bought and developed on, and we take pride in building everything from scratch, so we hope to really show up for that. Here's some progress that we've been making. It's been a team for around 2.5 years, and we recently were just able to get it standing, which has been a very big victory. As you heard from the other teams, Maryland Day is a big deal, so we were able to reach this milestone just in time, probably the day before, as most engineering projects go. And something to note is that as we then get these legs to the position of standing, it wants to hold that position. These are quasi-direct drive motors that actually have torque sensing. So you can see Justin there pushing on Test2Dog. It's able to recognize the force being pressed against it and respond accordingly. And then on the right, you can see a pretty typical obstacle avoidance for our basic simulation. All right, and we got one more team. I know I'm throwing a lot at you. We have Terry the Terraformer and a Flying Turtle. We have a lot of R&D that's been going on with this group. The main goal is to produce a Mars rover with the idea of simulating being in space, even though obviously we can't do so. And they were trying to come up with a lot of really interesting ideas to stand out during the competition. One of those is an omni-gear arm. It's a novel sphere gear. The goal is to simplify the inverse kinematics by having more of a wrist-like actuation. So it will have these gears that can actually grip onto it axially as well as in the direction of travel. That way you can produce more complicated motions on one joint. And then they ended up using a main linear driven arm to do most of its science. Here's some more R&D. Briefly, sorry. We have the bogey suspension, which is very typical for Mars rovers to avoid obstacles. And then they've been going on different wheel designs, including tri-tracks, which molds to the terrain. That was the main goal. You can see the FEA analysis of another wheel type deforming to the terrain. And then we actually have a terrain tester that we made with it's basically wooden steps. We were able to modify the heights and the incline from there, see the effectiveness of this. And then here's our drone. It hasn't been working yet, but we're hoping to get it working soon. It takes off as a hexacopter. So you can imagine that photo on the top left being vertical. It can take off basically like a rocket ship, and then it can turn horizontally and cruise as a fixed wing. And then for this block diagram, the goal is to have a very modular system that a robot arm can then remove the battery of and quickly swap out batteries. That way you can do more consistent and reliable testing on Mars.
Yeah, so just really quickly, here at Robotics at Maryland, something that's very, very important to us is that we are privileged to be supported by organizations like the MRC, and I think it's also important to kind of propagate that idea that robotics, you're here to learn, and we want as many people to learn as possible. That's why we have all these different different projects, because we're really trying to be open and really spread the love of robotics for everyone who is willing to just take a couple weekends off in order to work on these projects. Here at Robotics at Maryland, we like to say, we will give you the experience, the tools you need in order to, really feel like you can make anything and build anything. And in return, we only ask that you try to learn and build for each other and your community. So next slide. So we also try to do as much outreach as possible. We talk to younger teams. We talk to First Robotics and a lot of different. We also like to show up for Maryland Day, of course, and try to go around and show what we're working with. We also have special workshops workshops for our newer members so that they can really get out of the classroom and start getting their hands on some manufacturing methods. So yeah.
Yeah, and if you have any questions, we have a website as well as an Instagram, or you can just come talk to us at the table. Thank you so much.